Hello, everyone. Welcome to the Career Tech Hacks podcast, from where we discuss working high tech with people who are taking charge on their careers. So I'm Rodrigo Moutin, your host, and today's technology leader is Carlos Fernandes. Carlos is a software engineer, a Java developer, Linux container passionate, and Docker enthusiast. And he helps server-side developers to build containerized applications. Welcome to the show, Carlos.
Oh, hello, Rodrigo. Nice to be here.
Likewise, man. Very nice to have you here. And as always, we always have a special guest here. So today we have Rafael Leonardo, that is a Java developer that loves to hunt bugs, and he runs the nobugsproject.com, helping Java developers to use the best programming practice to code quality software for stress-free projects with fewer bugs. Welcome to the show, Rafael.
Thanks for introducing me, Rodrigo, and I'm really glad to be here.
Great. And we also have Sebastian Politia. I always, it's difficult for me to say this name, but he's a Java developer, microservice specialist, helping polyglot developers to deliver features to the business faster and become a role model in their projects. He also runs the JavaTechnicalWealth.com. Welcome to the show, Sebastian.
Hey everyone, great to be here and looking forward to hear what Carlos has to say. Like, very interesting subject.
Yeah, sure. And we also have Edilson Silva that helps junior developers to use agile mindset to their projects so they can become senior developer faster. Welcome to the show, Edilson.
Thank you, Rodrigo. Thank you, guys. It's nice to be here, and I also look forward to hear Carlos.
Yeah. So let's get started, Carlos. So I know you are a Java developer, but what leads you to the Linux and container world? Why Linux container matter?
I come from the command line interface than a graphical user interface. So Linux and Unix is not something that is new for me. I have been working with it for so long, and now as we have been working with now for using cloud computing application, and containers become very important, as containers is the base for cloud native application. And developers that have this knowledge about what is a container, that knows about Linux operating system, how it works, how the features that Linux container have, and know about Unix as well, and have some advantage to build application for the cloud, to build the cloud native application. So it's why it's so important nowadays to have this knowledge about containers, as it is the basis for a cloud native application.
Yep. And what is a Linux container?
Linux container is a collection. It's fun because when I start to think about it, when I start to work with Docker, for instance, that is an amazing product to build containers, and this name container, actually it's someone put a label on a collection of features that a Linux container have. So I think everything in a Linux operating system is a container. Everything there. So when you simply log in on a Linux operating system, you receive namespace, we receive amount of memory to work with, we receive disk space, you have your own file system. So it's what we're calling containers actually is all those features that we find on a Linux operating system. They created this this name is the way that the industry find to make business, and put everything inside a bag, a box, and in order to sell it in service or products. But when you look and try to understand what is a container, you figure out that it's only a collection of features that Linux operating system have, in very old features.
Yeah, but I know that you are a Java developer for many years. So what is the context that you find this Linux word or this container word on your career? When it was the time that you saw, maybe you saw this Linux container for the first time? Because I know you are not a system admin, you like to code. So what it was the context that it entered on your career?
I started to work 3 decades ago, and I spent my first year as a developer was developing application for mainframe using COBOL language. Very different environment, very different language, but after 1 year. Almost 1 year doing it, I had the opportunity to change my career for the first time and work for a different architecture and using Unix operating system. So it was the first time that I had this opportunity to interact with the computer using terminal shell, interacting, not only write code, but interact with the hardware, using an operating system. So I had this amazing experience using a Unix operating system, and from there I already had this idea of have multiple file system in order to run my application. So I could segregate the place where I was running my application. I had this idea 3 decades ago, and using a Unix operating system. When I had to move forward very fast, when I started to work with Linux operating system, maybe almost 2 decades ago, and I had this reconnection with the Unix operating system. Linux is very similar to Unix, but I find out that Linux was a more improved, have more improvement from Linux. So we have there more features that we can manage the application that we can run on this operating system, and it's very interesting. When you can segregate things running in the same machine, and you can isolate process, you can avoid that one process can interfere in other process. And talking about container is hard to not talk about Docker. That is a very popular tool or product to work with, to build up containers, to run containers. And the first contact that I had with Docker was 5 years ago, and 4 or 5 years ago. And at the first time, in my mind, it was like, it seems a virtual machine, it seems a hypervisor, but for my surprise, it wasn't the case. It was only a tool for manage those features that Linux have, that change the space where I can place my application, change the area that one application can see other application running, set up the amounts of resources that my application can consume from my hardware. So it was suddenly I start to link the dots that I had in my mind, because I knew about all those features, that amazing feature that Linux have, but suddenly I could think more about the entire context of what is a container, and nowadays it's become very important for those building cloud native application, as it is the basis. Everything run on the cloud are running inside a container. Even if you don't want it to be run in a container, it's running in a container there. So it's, if you know about containers, how to use containers, I think you have some levels of advantage over other developers, other IT professionals.
Absolutely. And is very, very known on the market, but not a couple of years ago, some years ago, the top thing, it was virtual machines. So you think Docker and containers could replace the virtual machine and hypervisor?
They are different technologies, and I think one can complete the other. Virtual machine, you think you need to note that and think that when you are using a virtual machine or hypervisor to build a virtual machine, you are, as the name says, you are virtualizing an entire machine, and it's not only the operating system. You are not to virtualize Windows or Linux there. You are virtualizing the motherboard, the hard disk, the memory, the processor, everything. So you have overhead here. You are building a new machine. On the other hand, containers is not a virtualization. You are only saying, oh, I want to run this application in a different part of my file system. And you can when you look to your file system, you know that you have a root folder, and you have under this root folder hierarchical structure of folders under this root folder. And in Linux, you can change this file system. You can create a different root and a different file system inside this file system. It's like, you think about, maybe if you are a developer, you have this idea about Git. You have your master branch, and you can create a future branch. So in Linux, you can do it very, very fast, in a very efficient way. You can create this new branch of your file system. So your application will see only this new root that you had created, and stop seeing the main root. So you can, it's a way that you can it's a very nice way to isolate your application. For instance, if you in a complete file system have several features there, several commands, and maybe one application can interact with this other commands in a way that you don't want. So you can create a segregated file system with only small parts of your main file system, and run your application in a more secure way.
Yeah,
so
and
the difference, the basic difference of virtual machine and container is that you're not virtualizing an entire machine. You are taking rebuilding your file system. In a nutshell, is it you're rebuilding one part of your file system, and you start to interact. Your application will start to interact with your kernel using only this small part. So it's different of virtualize an entire computer.
So considering this parts that a container gives you on the regarding to virtual machine that gives you the entire machine, so the container will give you only a piece of this. Which kind of application can be inside of these containers, these Linux containers?
Any application that you can run on your computer can run on a container, because it's the same. For this idea of Linux container is you are using your computer, the same operating system. You have the same. You're not using a different operating system when running a container. You are using your main operating system. You're using your kernel, the same kernel. You're using the same machine. So any application that you can install in this machine that you are using can run in a container. Any application that you can place in your file system, you can run in a container. It's only container is only a matter of segregate this, create a separated area to run this application. But actually, you are running in the same operating system, in the same, using the same kernel.
Yeah, and go. Okay, go.
It's when you think, I think when you think about operating system, and you can split the operating system in several ways. But I think the simplest way is to think about in two parts: the kernel and the user space. And in the user space, you can think that is that part where you can interact with your computer. So think about this, your graphical interface, your file system. All this is part of your user interface. And you have the kernel. The kernel has this, is near to your hardware. And they can understand your memory, your processor, your network interface, and you need your user interface is help you to interact with the kernel that is interact with your hardware. So when you think about containers, you work only in this user interface. You can rebuild your own user interface in order to run an application. You don't need to virtualize anything there. You only need to change using Linux commands or products such as Docker to change this area where your application will interact with your kernel.
Great, and trying to go a little deeper on this specific thing of Linux containers. I know before the show you told me that the CH root has about 36 years. So which other kernel features you can use to create containers on Linux, this CH root and things like this? So how these things happens?
As I said before, when you think Linux container, what we are calling container is everything that Linux have. But I can highlight three main features that Linux have that is the basis of what you will have when you are running a container. The very first thing when you are running a container is the change root. So you are saying to your system, I will run this application. Instant running in this file system will change the root and run my application in this different file system. So now my application will only see this part of this file system that I had created. So it's change root is a very important thing. And when you simply, for those that knows Docker, when you simply type Docker run, the very first thing is change the root for a file system, this file system. And this file system is the name of your container, this image that you have on the Docker image. So it's the beginning of running a container, is change the root. The second, Linux have this namespace idea. So you can say, in the same way that you have a file system to place this application, every run application receives identification in the process. So we have this hierarchical structure of process that have an ID for your running application. So using namespace, you can create a new table of process identification in a way that one process can't see other process. You can create, using namespace, you can isolate this process inside your processor, and make them isolate from your main tree of process. So it's every time that you are run a Docker type of Docker run, you are creating a new namespace for your running application. So it's a second level of isolation. The first one is isolate the place. The second one is isolate the process. And the third feature that is very important is control groups. Control groups, you can say, this application will use this amount of memory, you use this amount of space disk, you use only this part of my I/O. So it's you can limit all the resources that your application can consume from your computer. So change root is the oldest features that I can remember, those related to containers, and it comes from Unix operating system. Is not originally from Linux, but namespace and control groups have more than a decade, and it was developed for Linux. It has Google and IBM behind its development, and you are using it for more than 10 years. So all those features that it seems new for us when you are using products such as Docker, that seems new, but actually are very old. And it's because it is very common for system administrators using those features from Linux, and Docker help us as a developer to use those features that once was in a different style only for system admin, and now as a developer you can use those features without to know about it. It's a level of abstraction that Docker can give us.
I think what you're saying, it's also the next thing that I would ask you. What is Docker giving so much related to Linux containers? So what Docker give us that Linux containers maybe does not give us before? I don't know how. What do you think about this?
This Docker was a tool that was created for a company that originally was created for cloud services. So when they started the company as a cloud provider, cloud service, they figure out, we need to build up some tool that can help us to deal with those features that Linux have. At the end, they figure out the instant to provide the cloud service, our product is Docker, because it's an amazing tool. With this tool, and the way they build this tool is the guys behind it have this developer mindset, because when you look for the commands the Docker has is build, run, push, pull, commit. It's something that developers are using when they are building their application, when they are committing on a repository, and so it was easy for developers to use Docker, because they have those commands that are very similar to those that, for instance, Apache Maven have. The Git use to version your application. So it was a third tool. I have a tool to build my application. I have a tool to create a version of an application, to control the version of my application. Now I have a tool that can wrap up my application and deploy it in some cloud environment. So it was very easy for developers to start work with Docker, and why it becomes so popular. Before, you already have some products before Docker that were trying to deliver this level of functionality to developers. But Docker, I think the guys behind Docker knew how to deliver it in a very neat, in a very nice way for developers.
Yeah, I really agree with you on that aspect of Docker having some really good commands, and on their most recent version, they also created a management tool, so it's got even easier to understand the commands, because you type Docker container, so you know that everything that you're doing, it's related to containers. Docker volume, so you know it's volume things. Docker image, so that you even can, because before you just do things like Docker, I don't know what is that. I know that there are some commands that you can use an image or a container. So maybe some kind of some commands you maybe need some dash help to understand. But now I think the management command, it's get even easier to use containers.
Yes, and another thing that Docker has that is amazing is how it managed the file system. We are talking about the change root, that is create a new file system, and Docker has this management of the file system that is very interesting. They have it in layers, so they can for instance, for those who using Docker, every time that you type there Docker image ls, for instance, I don't know, to list the image that you have, maybe, and you look for the disk space that those image are using. Maybe you should sum it up. Maybe you figure out, oh, it's consuming 20 gigabytes of my disk space, but it's not the truth, because maybe your image have all those image have some parts that is common to each other. So Docker knows about it. So instead to have this 10, 20 gigabytes used by your disk space, actually it is consuming maybe 10% of it. If you have, if your file system, if your image is started have this same base, for instance, you start a image using, I don't know, Ubuntu, and all your image that you have on your file system are using Ubuntu. So you don't need to Docker is not repeating, and they are only take the same area of the file system in order to build a new image. So it's reducing the footprint of your file system. I think it's a very interesting thing.
Yeah, and do you think that the way that Docker packaged the containers was the really changing to the industry, the way that they package the containers and give us this ability to put the container in any places, and it's so easy to create a package that you, like you said, you get this Ubuntu, create some layers of your application that maybe it's just a couple of megabytes, and then you have a end container. You think that this the way that Docker packaged the application is the really changing on how Docker arise on the market?
You have two different aspects of this. When running your computer, this layers structure of your file system is very interesting. Is more efficient than have it repeat this file system. For instance, you have 10 different applications that you want to run each one in a different container, but you can use, but the base of running those containers is the same. So you don't need to have this 10 different file system. You have the same file system, and what Docker can do is to, when it run a container, they use the same file system and put only this specific application inside this container. So you can manage your disk space in the smart way. But the amazing thing is that you can, when you can move around this container, this image, in two different ways. One is that I have a registry, like a Docker Hub, like a GitHub, where I can put my image there. So another machine can pull this image in order to run it. Or I don't have Docker in my server side, is using a different technology. Is what is amazing about Docker and about Linux container. I don't have Docker. I don't like to use Docker. I don't like Docker. I don't want Docker in my server computer. I can export it in a tarball and run it in this server that I have with Linux without Docker. I can change the root and run my application there. It doesn't matter. So I can, even without using Docker, I can use this container that I had created before in my laptop, in my workstation at work. Doesn't matter. So Docker is still a very useful way to speed up the way that you can manage and run your container. But at the same time, you can start building your container using Docker, and it can end up in some server around the world without need to have Docker installed inside this machine. You can simply use the Linux commands to run those containers. I don't think nowadays it's so practical to do it, but it's only an example of the freedom that you have, when you're using Linux. You're not locked in a vendor. You're not locked in, I build up this in Docker. Now I have to install Docker on my server. No, it's not the case. You can run it using a different tool. You can run it using a competitor from Docker. You can run it using CoreOS Rocket. Nowadays it's from Red Hat, for instance. Doesn't matter. You can use it using some connector for Kubernetes. You have choice. Developers can use Docker on their machine, and the server side can use a different product. It doesn't matter.
Yeah, it was pretty the next question that I would ask you, that what if there is any other company that compete with Docker on this market.
I think it's not. I can say the competitor, but the thing that I think at the end Docker will. It seems maybe I'm wrong. Maybe Docker will, at the same way that it starts to become very popular, suddenly we will forget about it. And I say why? Kubernetes. Kubernetes is a tool to manage those containers, and it is create a new layer of abstraction that we are forget about Docker. You are building your application and send it to to the cloud, and there it's running in some adapter for Kubernetes that are taking this container that you had created on your machine and running it and managing it. And they don't know about Docker when on the server side. They only know about the Kubernetes. And so it seems the Kubernetes is taking over this container world, and suddenly it will become something that we will forget about. It seems to me, and then in the pace that we are walking, it's and evolving. It seems that we stop using. We stop talking about Docker. We start talking about only Kubernetes. It seems to me.
Yeah, and a lot of great stuff here about the Linux container that you're talking a lot about the developers. So it's a kind of tool that will help a lot us on our careers. And I know that you're also a lover of cloud native applications. So what these Docker things and these Kubernetes things and Linux containers are related to cloud native?
You think that cloud computing offering you a way to reduce your costs in infrastructure, but the cloud, what differs when you think about cloud computing, you can at the beginning, I think it's that data center, it's cloud. We are calling the cloud, but we are put a new label on data center, simply cloud computing. But the reality is a different mindset for data center. So the idea is you stop think about your operating system. You stop think about your server application, your server application. Not only about the hardware, but about the software. And the best way to take advantage from the cloud computing is not only to stop running your application on-premise or your old data center and move your application to cloud computing. The best way is to change the way that you build your application. And it means that using, for instance, the microservice architecture. And when you have different places to run, to build, run your application, it's simple, very, very easy when you think about boxes. And imagine that you have shelves and you can organize all your stuffs in boxes. So anytime that you need to replace something or take something and put new things inside this box, you can take this box and put on your lap and manage the things there, and take this box again and place again on the shelf. Or you can remove this box from the shelf and put a new one in the shelf. And containers is a very easy way to do it. You can start to build your box in your machine, put your application there. Instead to have your monolithic application, you can have now, as we are using this amazing features that is containers, you can have several parts of your application, each one inside this different box. And when you finish testing and building, testing your application, you can take this box and put on the shelf. And the shelf is the cloud where it is running. And you don't know about what I am using there, which machine. I don't know about machine there. I don't have more this idea about server. I only have this idea about my box, my container. And the evolution of it is the serverless. The serverless will give us this idea. I don't have more server. I don't have more. For those using Java, I don't have more Tomcat, Apache Tomcat. I don't have more WebLogic. I don't have more JBoss. I don't have more any server. I only need to think about my application, because serverless means that in the cloud I have a container there that have all the layers that I need. I have my operating system. I have the JVM. I have the Apache Tomcat there. I only need the last layer that I need in my container is my application. So I only need to think about my application. Is the serverless. Actually, serverless from our point of view. Of course, there they have a server. But from our point of view of the application, is a serverless. You can stop thinking about all those products, the technology that are not related with your application. Only you will create your servlet, your Java servlet, you're running, build it, package it on a jar file, and simply deploy it on a serverless infrastructure in the cloud that are using container technology. So it's why it's important for those technology based on containers, orchestrations like orchestrators such as Kubernetes. Maybe you can use Docker Swarm, Apache Mesos, but to have these orchestrators and microservice. In order to build a cloud-native application, you need to understand those three important things. Containers, that is the basis of cloud-native. Orchestrators, that is the way that you can manage those containers, those running containers, and microservices. So if you master those three things, you can build a cloud native application, and or at least understand what's going on the server side, on the cloud nowadays.
Awesome. Very nice to see this whole perspective, since from the beginning, like I don't know anything about Linux containers, and now you know Linux containers, you know Docker, you know containers on a very greater perspective, and you know that you need the next step is maybe Kubernetes and things like this, and the microservice that is a business. It's very nice, this perspective that you give us. So let's get some extra questions. Do you have questions, Rafael?
Yeah, I would like to ask Carlos if there are many advantages of using Docker on Linux, or for example, using Docker or in Mac and Windows, we lose a lot of benefits. So I would like to know your opinion. How is it exactly?
Yes. When using Docker on Unix or on Unix machine, such as Mac, or using on a Windows machine, you have you need a broker there that is the hypervisor, because Docker is a product that is running on a Linux. So you need on Windows. We have this Hyper-V is the best way to run Linux on Windows, but still it's not the same on running Docker on a Linux machine, because on Linux you don't have a hypervisor in the middle. You don't need to virtualize anything. Windows, you are consuming more resources for your machine. You need more memory, you need more processor, because you need to use a hypervisor. And so the best way of using Linux container is using a Linux machine, not using a Windows. But you know, when you work for a big company, usually you don't have the choice of the operating system that is running on your workstation. Usually they are running Windows, and you still can run Docker there. But if you have opportunity to use it on a Linux machine, you note that it has some difference of performance and some buggy issues as well. So it's better to use it in a Linux machine, or use it if you are using a Mac or a Windows. Maybe the best experience is running it inside virtual machines that you have more control. But the problem is when you have to interact with your host machine and this virtual machine where you are running your Docker. Sometimes you have problem with the IP address, or some network problem. It's not the same. I'm using at work. I use there at work. I use Windows. I don't have choice, so I need to use the behind the scenes. I have this Hyper-V that is very efficient. Hyper-V is better than use VirtualBox, but it's not the same when I'm using at home with my laptop. Windows have some advantage of Mac. Because Windows have changed the way of business and decide to give to their users a subsystem for Linux. So if you are using Windows 10, for instance, you can install a subsystem there. So you can have a Linux inside the Windows. So you can use Docker in a more efficient way that using on a regular Windows. And so it's they are trying to figure out how to solve the problems. They know that many people don't have the choice of which operating system they can use. Many places the Windows is mandatory, and so they are trying to figure out how to help those developers that I want to learn about Docker, I want to use Docker, but how I can use it? I have this solution for you, but it's not the best. Microsoft have been invest a lot in Docker to make it more seamless for Windows users, but I don't know if you know about it, but Microsoft nowadays have its own Linux distro. is showing that Linux is very important for them and very important for the world. And Windows have more this use on workstation for this corporate world. And if you Linux is a how do I say? I'm a fan from Linux operating system, but I'm not being biased about it. But Linux is you can compare this Linux operating system, how it this amazing kernel that it have. I think you can't find another operating system today that is more advanced than Linux. When you look for features that you have there, and of course it's because the open source community. So it's if you have a choice, move to Linux, and it's the best way to use Linux container.
It's great. Thank you, Carlos.
What about you, Sebastian? Do you have any question?
I got one, actually. I was wondering if there's anything that we need to take care or to consider when we want to use Docker to contain specifically Java or JVM applications in terms of heap size or number of CPU. Like I read an article saying that I think it's better now, but like there were times where like the number of core from the Java application was not like was stating like was still calculating based on the total size of all the resource of the machine instead of specifically what's allowed in your Docker context. So is there anything that was addressed regarding that?
And when we start to it's the same. Let's think about the without a container, and I think I can think about this scenario when you are running offline application. That is a very common scenario for Java applications. It's not only inside the server, a server container, such as Docker, such as Tomcat or WebLogic. Most of applications, Java applications, run in only using JVM. You have this command line is a Java batch application. So every time that you are running a Java batch application, and you can have thousands and thousands of Java application running in the same application, you are start a new JVM instance, not using the same JVM. So you have multiple JVM process. If you look to your list of running process, you have several different JVM there. And what you need to think, not when running it on the server using containers on the server side, I think it's the same idea that you have to have in mind, the same idea that you have when you are not using containers, because at the end it's the same. Maybe if you are running using tools like Docker, you don't have this control. I'm not controlling so well about the amount of resources. When you run it, usually you are running it in the default mode. You are simply Docker run and type your application there. So you're not worried about to understand the Docker as application. You as a developer don't understand features that the operating system have, features about your hardware, and you are only think about running Docker on the server side the same way you are running on your workstation. Is a problem. You need to understand. I think it's the case when a sysadmin can manage it better. And the reason nowadays that you have some standards for running containers on the server side, for instance, we have the Open Container Initiative, that is an organization below Linux Foundation. We have the Cloud Native Computing Foundation. All those, and you have more organizations that are trying to create standards, try to, as Docker becomes so popular, to push for some changes in this product, to be more open, to allow, how I said before, I can create Docker, a container using Docker in my workstation, and I can run it on the server side without Docker. Because what I have been seeing is that for the perspective of system administrators, they have some worries about this product, Docker. It's a daemon running in my server. I don't know exactly what's going on when it's running. I don't know how to manage some security issues that Docker have. So what I want is my developer can build this container using Docker, but at the end I can run it using a different way, in the way that I know how to manage it. I know how to run a Java application in my server. I know how to manage the JVM setup there, to manage memory, resource. I know how to deal with JVM running in this hardware. I can do the same. I can decide how to run it, to set up this JVM in the better way to run this application in my server. So, and I think the most articles that you can find on the internet is relate more a Docker, and is And those writing those articles, I think more as a developer. I am using Docker in my workstation. I have some security issue here. I have more. It's take more resources that I want. I don't know how to change it, but at the end of the day, this application will be run in some place not using Docker. It's a very common. You have two main products that was splitted from Docker. One is the most important is runC. Is a project from the OCI, the Open Container Initiative, runC. That is a very simple application that can run this tarball that was created using Docker. So I think it's the best way to run a container on the server side is using this runC. It's not a daemon on your server. It's only a command, and you only using the change root and try to use the configuration for your namespace and control groups, and it's finished. And your only thing that is running your application, not a product like Docker there. And the other product that is very important for this container scenario is Containerd. Containerd is a product from Cloud Native Computer Foundation, and is when you can is a daemon. Now is a daemon that you are installing on the server side, but is something that is more reliable that using Docker on the server side. It's something that system administrator can manage than Docker. Then something that they can understand more than Docker. They don't need to think about and to worry about, I need to run a new patch in my system because Docker. They can use those more simple tools that are standard for the market and more secure to run those containers. So Docker of course, have some issues, but I think the best part, and you can forget about those issues, and when you are running it on your workstation for development, in order to help you to manage how to build your container, how to test it. But when you move this container that you have built on your workstation, it can end up in a server that doesn't need Docker. So I think this is the answer for those issues that you have been reading on several articles and about memory and so on and so forth.
Okay, so it's transparent. So
yes.
Okay.
Many systems. I like to read and follow those problems, and what I can say is that many system administrator have this problem with Docker. To worry, and the nightmare for system administrators seems to have a new daemon. That is a new process that is running by default. Every time that I start up a machine, I have this process running. So it is something that they have to deal with, something that they have to worry with. And so they have been pushing the container technology in a way that they can run containers there without have a daemon running in this server. So Docker has become more a tool that can be very useful for the time you are building your container. You're trying to figure out what you need in this container, how your application will run in this container. And at the end, it can end up in a server side, only managed for Kubernetes, for instance, without Docker.
Great. Great. So guys, any more questions? We are on the top of the hour. Maybe some final, anyone have some final thoughts that want to share?
Well, that was great. That was beyond. We learned a few things. It's not just a buzzword like containers. To actually have an idea of how it's implemented. That makes it easier to understand, and might even help like when we're actually using those containers technologies to use them more efficiently when we actually know what's going on under the hood. So it's pretty good.
Yeah. Thank you, Carlos. You could give us a really good view about Docker and containers, how it works behind the scenes with Linux. Because actually Docker is something that was created a long time ago with Linux, and it's very useful. It's, as you said, all developers have to know that nowadays. So thank you for your presentation.
Thank
you. And I also end up with the final question to you, Carlos. What are the things that containers, Linux containers, all this stuff that we talk about today can help us on our careers?
How it can help you?
Yeah, let me rephrase it because it's a little confusing. So on our developers' careers, learning and knowing containers matters. So know about all these stuffs will help us to grow on our careers. And
as people organizations move into the cloud computing research in order to run their applications, knowing about the environment where you are running your application, where you are developing, is very important. So containers is the same. It's important. Forgetting about containers, it's important for us to understand the operating system where we are running our application. It's important. We need to install tools, we need to run application, and we need to interact with this operating system. We need to understand the operating system. And container is the same. As your application is now have a new layer over the operating system, that is the container. So we need to try to understand this new operating system, if I can say, that is the container, is the new environment or where your application is running. And for developers that understand it, it's an advantage because they will understand how is the behavior of this my application on the server side, and in my and the behavior of this application on my workstation. They will start to understand that this I can replicate the same thing that I have on the server side now. I can replicate the same space where the same environment, the same space where my application is running on the server side. Now I can replicate it on my my workstation. The most common answer when we have a bug on the server is that, well, wow, on my machine it's working well. It's the answer. Oh, it's working well. And so I wish I had the opportunity to put my machine on the production. So you can now. using containers. You can your container does this container that is running with some bug on the server side. You can take this container to push this container that has a bug. You can pull this container to your workstation, work inside this container, try to figure out what's going on inside this container. And when you decide, oh, it's okay, it's running, this container is running very well in my machine, I can move this container to the server side, and will work in the same way that it was working in my workstation, because the environment, this space that I had created, the file system, all the configurations are the same. So it's an incredible advantage for developers to understand. So they can, when they know how to deal with container, it seems that they know how to solve the problems, and today those who knows how to build cloud native applications that use in container have more opportunities, more job opportunities, and have more chance to grow in their career. And it's how important to know about container. That is the basis of cloud native application.
Awesome. Thank you very much, Carlos, for being here on this amazing interview. It was very nice to know everything about Docker, Linux, containers, and so on. And also special thanks to Rafael and Sebastian, our special guests today. And we are wrapping up the second episode of Tech Career Hacks, and hope to see you on the next episode. See you. Bye-bye.
See you, guys.
Thank you.